Today we're going to look at section 2.5. Section 2.5 is all about applying addition and subtraction properties of segments and angles. So we have several theorems. Theorems are mathematical statements that can be proved. So the first theorem says if a segment is added to two congruent segments, then the sums are congruent. It's the same thing if I replace the word segment with angles. So if an angle is added to two congruent angles, then the sums are congruent. The other theorem we have is that if two congruent segments are added to congruent segments, then the sums are congruent. I can replace the word segment with angles. If congruent angles are added to congruent angles, then the sums are congruent. We refer to these two theorems as the addition property. So what both of these things are saying is that if you take two small pieces and put them together, you're making something bigger. Well, that's the idea behind addition. Add two small numbers, you get a bigger number. Let's look at two other theorems. It says if a segment is subtracted from two congruent segments, then the differences are congruent. Or if an angle is subtracted from two congruent angles, then the differences are congruent. The second theorem says if congruent segments are subtracted from congruent segments, then the differences are congruent. Replace that with angles. If congruent angles are subtracted from congruent angles, then the differences are congruent. So these two are dealing with subtracting. We can refer to these two as the subtraction property. So that means we're starting with something big and our final answer is something smaller. Because think about subtraction, you start with a number. When you subtract something, you're taking it away, making it smaller. So we're going to take the idea of addition and subtraction, something that we've been doing since elementary school, but now we're going to be applying it into a geometry aspect. So these examples here, the first one says to name the segments congruent by the subtraction property. So as you can see, there's some markings in the picture. So I'm going to highlight some stuff. So the fact that notice that this segment of KO is marked with one tick mark, and so is this segment of KP. So those two segments are congruent. Notice that I also have this segment of NO and this segment of RP. They both have two tick marks, so those two are congruent. So as you can see in the picture, we can't assume, but it appears that KO and KP are bigger than NO and RP. And notice that if I'm talking about subtracting, well, if I take those smaller pieces away from the bigger pieces, hopefully you notice that what's left over are these two pieces here that I have circled. So the segments that are congruent because of subtraction would be the segment NK, and that would have to be congruent to the segment KR. And so let me just justify this with some numbers. So say we had 10 for the length of those two segments, and say we have 2 for the length of those two segments. Well, hopefully it's okay then that this piece of KN, that would have to be 8, because 10 minus 2 is 8. Put 8 and 2 back together, you get 10. Same thing here. This would have to be 8 because 10 minus 2 is 8. So that's the subtraction property. In the second one, it says name the angles that are congruent by the addition property. So once again, I'm going to start highlighting things that I see in the picture. So notice that this angle of EHF, essentially I didn't go all the way over there, that has this marking. And so over here, the angle of FGE, those are the same markings. So those two angles are congruent. I also have this angle of GHF and this angle of HGE. Those are marked the same. So those are congruent. So if we want to find something that's congruent by addition, well, addition means that I'm taking pieces that are small and putting them together to make something big. Hopefully we notice that these two pieces over here on the left share a vertex of H. So put it together and we have a bigger angle of EHG. And so those two little pieces, since they are congruent to these two little pieces here, which are on the right, are shared with the vertex of G, I can say that they're congruent to the angle of FGH. And so once again, if you justify it with some numbers, say I had a 50-degree angle with this angle of EHF, so this has to be 50. And then say I've got these little angles that are 20. Well, 50 and 20, if I add those together, it gives me that big angle to be 70 degrees. And then same thing on the right, add the 20 and the 50, and you get the bigger angle G, which also is 70. So that just justifies why those two angles are congruent. All right, so next I'm going to look at the given information, decide what I can conclude, and then justify it with a reason. So I'm given that the segment GH, so this segment right here, that's congruent to the segment of HK. So I marked those two segments congruent. That's the only piece of information that I know. I want to determine what I can conclude. Well, hopefully we can see in this picture that those two segments that I marked as congruent, they actually overlap. They overlap at this piece right here. So both of those big segments of GH and HK, they have the segment HJ in it. So think about it. If I'm starting with segments that are bigger and they share something in common, well, take it away, and what we'll be left over with is going to have to be congruent. So this right here, this segment of GH would have to be congruent to this segment over here of JK. And so once again, I'll just justify it with numbers, but then we'll write an if-then sentence or a justification. So say those two segments that we just said were congruent, because that was what was given, were both a length of 12. What they overlapped at, let's say that's a length of 8. So think about it. Take away that one piece that they have in common, and this would have to be 4, because 4 and 8 is 12. And over here, that would have to be 4, because 8 and 4 is 12. So that's why those two are congruent. So if I'm starting with something big and I'm concluding something small, that's because of the subtraction property. So in this case, because it's a property, we don't have to specifically say an if-then sentence. Subtraction property is enough justification to conclude what we concluded. So let's take a look at this next one. So we are given that the segment AB, I'm going to mark it, is congruent to the segment FE. So those get the same tick marks. I'm also told that the segment BC is congruent to the segment of ED. So I gave those 2 tick marks. So those 2 are congruent. The ones on the right are congruent. We're trying to figure out what we can conclude. So for starting with 2 smaller sets of congruent pieces, well, think about it. If I put those 2 pieces together, on the top, it's creating the segment of AC. On the bottom, it's creating the segment of FD. But hopefully we notice that those 2 segments that I just highlighted, they're going to have to be congruent. And that would be my conclusion. The segment AC is congruent to the segment FD. So let's justify this. So once again, let's give them some numbers to kind of see why. So say that was 3, so that means this is 3. So then this is 5 and this is 5. So think about it. These 2 pieces, put them together, we get a length of 8. These 2 pieces, put them together, we get a length of 8. So to start with something small, but then get to something big, well, that's the addition property. So once again, because it's a property, we don't have to write an if-then sentence. That is enough justification. So in this next one, we are told that the ray SV and SU trisect the angle of RST. So remember, we've got a vocab word here, trisect. We have to ask ourselves, what does it mean to trisect? Well, hopefully remember, trisect means to divide into 3 congruent pieces. So our conclusion, we should have 3 things congruent. Notice that what comes after it is an angle, and if you look, the vertex is S. So it's these 3 smaller angles that all share the same vertex. So if I name them, it'd be the angle of RSV. That would be congruent to the angle of VSU, which would be congruent to the angle of UST. And so in this case, we have to come up with a justification. So this time we're going to do an if-then sentence. So since trisect was given, that's part of the if. So I have to give a broad statement. If an angle is trisected, okay, because that's what we're starting with. We're talking about an angle being trisected. Then, and now we have to justify, well, what did we conclude? Then the angle is divided into 3 congruent angles. So there's our if-then sentence justifying what we were given in our conclusion because of it. All right, let's look at this next one. It's an algebra problem. So I'm going to start marking out my picture. We know that the angle ABE, so that follow the letters from A to B to E is this whole thing right here. That's represented as 6x minus 31. We're told that angle DBC, so if I follow it, I'll do it with a different color. From D to B to C is this. That's represented as 3x plus 11. We're told that the angle of ABE is congruent to the angle of DBC. Okay, so right there, right off the bat, hopefully we notice that if I gave you 2 expressions for angles that are congruent, congruent means equals. So I'm going to go ahead and I'm going to set those 2 expressions equal to each other because I know I'm going to have to do something with x. So let's go ahead and solve for x. So I'm going to subtract 3x over to the other side. And then I'm going to add the 31. And then we'll divide by 3, and 42 divided by 3 is going to give us 14. Okay, let's see what the rest of this stuff says. It says that DBE is bisected. So if I follow the letters DBE, so I'll highlight that angle. If that's being bisected, well, remember, bisect means to divide into 2 congruent pieces. So that means that this angle and this angle are congruent. We're told that angle DBE is 30 degrees. Okay, so if it's 30, that means that cut that in half, each of these, well, that has to be 15 degrees because 15 and 15 will get us 30. So now that we've listed all of our given and we know everything, we know what x is, it says to find the measure of the angle ABD. Okay, so we want to figure out this little angle right there. All right, so notice that now that we know what the x value is, I can plug that back into those 2 expressions and I can figure out what the measure of the angle ABE and DBC is. So that's what I'm going to do. So the measure of the angle ABE. So I'll plug it into this one. It's essentially the same thing as DBC. We'll do 6 times 14 minus 31. So let's do that math. 6 times 14 is going to give us 84. I'll subtract 31 from it. And so we have a 53-degree angle. Okay, so notice that angle ABE is not only 53, but it's made up of 3 smaller angles. The angle that I want, and then the 2 angles that we now know are 15 degrees. So using that idea of then subtraction, because if I know a big angle and I'm trying to find something smaller, I want to subtract. So I'm going to take that 53 degrees and I'm going to subtract both of those 15, and that's going to get us our answer. So minus 15, or essentially you can subtract 30 from 53. And so the answer that we're looking for, the measure of the angle ABD, is 23 degrees. So that is us using addition and subtraction now in terms of geometry, so using it with segments and angles.